Morning all. Let me share my screen first. Okay. Is my screen visible? Okay. Okay. So today we are going to see flip-flop. Now, what is flip-flop? Basically, flip-flop is basic memory circuit or basic digital memory circuit. So you store the value here in flip-flop, right? So flip-flop is basic digital memory circuit. It has two state, one state and zero state. Obviously, digital circuit has two values, one and zero, which we need to store into memory, right? So basically, flip-flop is a digital memory circuit which stores either one state or zero state in memory, right? So in last lecture, I think we started with one bit memory cell. So one bit memory cell is basically a cross-coupled inverter. So for this, we are using either NAND gate or NOR gate, right, to form a one-bit memory cell. So if we consider a NAND gate here, then in that case, it is the arrangement of this NAND gate is like, output of one is connected to second's input and output of second NAND gate is connected as input to first. So this is basically called a one bit memory cell. So we see explanation here uh, in last lecture, right? So this is basically output. If we consider zero, it will store zero only. And this is a complement of the value which is stored in memory cell, right? So if we consider this is zero, then input of this is zero. So if this is zero, then this is inverter. This gate is called inverter. It inverted zero into one, right? If this output of second NAND gate is one, then input is connected as output of input of first is connected as output of second. Then this becomes one, right? If this is one, G1 is inverter again, or first NAND gate is inverter again, so it inverted to zero, right? So this value holds there. So it stores actually zero there for so many iterations, right? So this is called a one bit memory cell or latch. It stores something there, right? Either it stores zero or one there inside the memory or inside the circuit, right? So this basically is a one bit memory cell or latch, right? We cannot store or we cannot set this latch uh, for 0 or 1. For that reason, again, we use two different NAND gates, right? If suppose this is my G1, G2, and this is basically a latch, then in that case, we cannot set or reset the values, right? So for that reason, another set of NAND gate is used to set and reset. This is called G3, G4. 4. In this case, if suppose this is treated to be as 0 and 1, in that case, it becomes 0 to 1 and this becomes 1, 1 to 0. If it is 0, that means Q bar becomes 1, right? If Q bar is 1, that means this is 0, right? So if we have 0 here and 1 here, that means the output is 0, or you can say reset. So you call this as reset input, right? And if we have 1 here and 0 as next input, then it becomes 0 here and 1 here. If it 0 is multiplied with anything, then it is 0 itself. So 0 is ANDed with anything is 0. So inverted value of 0 is 1. That means Q become 1 in next iteration, right? So if we have 1 as an input, Q becomes 1 here, right? So this is called a state of this flip-flop, or you can say 1-bit memory cell. So this is called a set reset flip-flop, right? Or states, right? So if it is 1 0, then this flip-flop is in set state, and if it is 0 1, then it is reset state. What if both are 0 and 0? If both are 0, that means it becomes 1 and 1 here. That means whatever is a second input, the output is depends on second input. So whatever is stored in 1-bit memory cell is keep there as it is, right? So we cannot have change here by applying 0 0. So whatever is in memory at this state, right, at 0 0 is keep as it is there in flip-flop or memory cell, right? So this is a second condition, right? So if we check so many conditions here, in case of 1 0, it sets flip-flop. In 0 1, it resets flip-flop. In 0 0 condition, whatever is there in Q is there as it is, right? So the value of Q, either it should be 0 or 1, it keeps that value as it is, right? So those are few conditions over there. Now next we'll check the condition is 1 1, right? What actually becomes if we pass 1 1 as a input, right? So if suppose this yes is also 1 and R is also 1, in that case, this is inverter. This is also inverter. If value is 1, what 1 is inverted into? Yes, 1 is inverted and it becomes 0. Exactly. 1 is inverted and it becomes 0. So both the inputs are 0. Obviously, if 0 is here, it doesn't care about this input. If 0 is there, it doesn't care about this input. Right? So it becomes 0 here. Right? It becomes 0 here. If both the NAND gates are 0 or this is 0, here again in inverter, it tries to become 1. Right? 0 is here, it tries to become 1, which is not possible. Why it is not possible? Because we earlier we see that if 1 or this is Q, this becomes Q bar, right? So both those outputs should be complementary, right? If this is 0, this should be 1. If this is 0, this should be 1. So both at a time cannot be 1, right? So this case is forbidden from ESR flip-flop. Why? Because both the output are trying to become 1, which is not possible or against rule. Why? Because if one output is Q, then another should be Q complement. So this case is forbidden, and which is written in truth table on is like question mark, right? This condition is prohibited from ESR flip-flop, right? So if S equal to 1 and R equal to 1, in that case, both the output Q and Q complement is trying to be 1, right? Right. So this case is forbidden, and which is not actually possible, which is against rules. So this condition is prohibited or forbidden from the circuit, right? So this is about ESR flip-flop. Till now, is it clear? Till now, is it clear? Okay. Uh, so next is clocked ESR flip flop. So this is my latch. S input, R input, Q and Q bar. Right. Now, what is clocked ESR flip flop? Right. So in this case, uh, okay. In this case, you whatever is input you passed from yes and R is converted and passed to next stage or to latch, right? So when actually it becomes, uh, when actually it converted from input to output, we cannot get exactly what could be there in a output of Q, right? Basically, this conversion is depends on propagation delay of each and every gate which is present over there, right? So we should pass this input in synchronous way or at a given point of time. If we pass input, then only we'll get the output. So we need to identify that time, right? For that reason, when another input is passed, and which is called as clocked input, this is a synchronous input, right? This is a synchronous input. As and when you pass this input, whatever is there inside the yes and R is converted and passed to latch, right? This is called a synchronous input. If clock equal to 1 1, then only all other things which are there on yes and R are converted. Otherwise, if it is 0, it is not going to pass whatever is there inside the yes and R, right? So if clock input is passed at that moment only, whatever inputs are there inside yes and R are converted to its output, right? This is what a clocked ESR flip flop. You can use this SR flip-flop or in synchronous way, right? At given point of time, you convert the value to from input to output, right? This is what a clocked SR flip-flop, right? Again, this SR flip-flop or clocked SR flip-flop has two more inputs, which are called preset and clear, right? So preset is nothing but the input which actually sets the flip-flop, and clear is the input which actually reset the flip-flop. And those are asynchronous inputs. Those are asynchronous inputs. So those inputs are there. This is preset input and this is clear input. So this bubble, which at the end of those wires, are showed that those inputs are active low, right? Active low, that means if you pass zero, at that moment only it will reset or it will set the output. So if suppose preset is 0 and clear is 1, at that moment whatever is there, it doesn't consider on those, whatever values are there on those two wires are doesn't consider. If it is 0, this becomes all 0 and 0 is inverted to 1. That means Q is 1. That means this is fed, right? If clear is 0 and preset is 1, so this becomes 0. Whatever is there is not considered. 0 into anything is 0 and converted to 1, right? Or inverted to 1. That means Q bar equal to 1. That means this is a, if Q bar is 1, that means Q equal to 0. This is the reset state, right? So those are called asynchronous input, right? Preset and clear. So how symbol look like for, oh sorry, yes and R flip flop? So block is used. This is my set. This is my reset. Q complement, right? So this is SR flip flop. Now this is clock input, again PR and CR or clear. So this is how a symbol for SR flip flop or clocked SR flip flop or SR flip flop with preset and clear input, right? So this is how symbol looks like in with preset and clear. ओके, हे समजलं का इथपर्यंत? हे समजलं का इथपर्यंत? ओके, कुणाला काही प्रॉब्लेम आहे का? कुणाला काही प्रॉब्लेम आहे का? प्रॉब्लेम असेल तर चॅट बॉक्स मध्ये टाका. काय नाही समजलं, ते नाही समजलं, ते नाही समजलं. समजलंय का? पटापट. नाही समजलं असं काही आहे का? ओके, प्रीसेट आणि क्लिअरचा यूज हो, डायरेक्टली असिंक्रोनस इनपुट आहे रे ते. प्रीसेट आणि क्लिअर डायरेक्ट इनपुट आहे. या केसमध्ये काय होतं, तर प्रीसेट आणि क्लिअरनी असिंक्रोनसली तुम्ही काय करू शकता, सेट किंवा रिसेट करू शकता. म्हणजे काय, तर सेट रिसेट करायला इनपुट आउटपुट द्यावं, रादर इनपुट असाइन करावे लागतात. जर सेट करायचं असेल तर 1-0 आणि रिसेट करायचं असेल तर 0-1 पास करायला लागतं ऍज अ इनपुट. इथं काय होतं आपल्याला काही काही केसमध्ये फ्लिप फ्लॉप सेट रिसेट मोडमध्ये टाकावं लागेल. आयदर तो सेट असावा किंवा रिसेट असावा. सो हे असिंक्रोनस इनपुट्स आहेत. प्रीसेट आणि क्लिअर आर असिंक्रोनस इनपुट. यू कॅन डिरेक्टली सेट और रिसेट फ्लिप फ्लॉप बाय अ सिंगल पिन ओनली. म्हणजे तुम्ही प्रीसेटला जर 0 डायरेक्टली दिलं तर तो सेट होऊन जाईल. क्लिअरला जर 0 डायरेक्टली दिलं तर तो रिसेट होऊन जाईल. राईट. सो ते असिंक्रोनस इनपुट आहेत. कधी कधी आपल्याला लागू शकतो की फ्लिप फ्लॉप सेट किंवा रिसेट मोडमध्ये असायला लागतो. सो त्या केसमध्ये डायरेक्टली एका पिनवर तुम्ही ऍक्टिव्ह लो सिग्नल पास केला तर त्या केसमध्ये काय होतं तो सेट किंवा रिसेट करता येतो डायरेक्टली. राईट. त्यासाठी इनपुट पास करून अख्ख्याच्या अख्खे जे काही गेट्स कनेक्ट केलेत त्याच्यातनं इनपुट आउटपुट पास नाही केलं तरी चालेल. राईट. एक पिन थ्रू तुम्ही डायरेक्टली काय करू शकता सेट किंवा आता एका इनपुट थ्रू तुम्ही सेट किंवा रिसेट करू शकता फ्लिप फ्लॉप. ओके. समजलं का? कोणीतरी विचारला होता प्रश्न हा. हे डायग्रामचं पण हा त्या डायग्रामचं पण काम झालं. ओके. चेक झाले ना? ओके. Now next is JK flip flop. Now what is JK? आता हे JK जे आहेत हे सायंटिस्ट आहेत जॅक अँड किल्बे. राईट. सो they are using SR flip flop, or they are working actually on SR flip flop, and they are trying to remove the forbidden state from J and sorry, yes and R flip flop. What is forbidden condition? Yes, if yes equal to 1 and R equal to 1, in that case we don't, rather the output is uncertain in that case, so that case is forbidden. So J and K, rather Jack and Kilby are the scientists actually working on this condition. And what actually they trying to do is they want to use yes equal to 1 and R equal to 1 and condition, and they want to come at some certain output, right? So what they did, they actually converted the input like, this, right? R equal to J Q, right? So they come up with this expression. What actually they did here is, see, I draw the diagram first. This is my G1, G2. This is latch. This is my yes and R, right? So what actually that they're trying to do is, yes is converted like, this. So they converted, this is my Q bar. So yes is converted like, Q is passing as feedback, and yes, and this pole is called J, right? And this Q is attached here, and this hole is called as Q, right? So this is how they convert it, right? Feedback connections are used in this case and as connected again to input, right? So Q is connected to R input and Q complement is connected to yes input, and the things are change, right? So if you suppose the inputs are 0, 1, and Q could be 0. If Q is 0, Q complement is 1, right? So this becomes 1, this becomes 0, right? So in that case, what it changes here, if suppose, no, okay, forget about other cases, consider 1, 1. कन्सिडर 1-1. बाकीच्या केसमध्ये 0-1-1-0 मध्ये सेट रिसेटच होणार आहे. जर त्यांनी S इक्वल टू R इक्वल टू 1 वर काम केलं तर आपण तीच कंडिशन पहिल्यांदा चेक करू, राईट? सो Q is connected to R and Q complement is connected to S. So if it is 1-1, that means this is 1. If it is 1 and Q is 0, then that becomes 0, right? So it is converted to 0, it is converted to 1. So if it is 0, right? If it is 0, then here it is 1. That means zeros to 1. If Q is 1, that means Q complement is 0, right? Now again, Q complement is Q complement is connected to here, and Q is connected to here, which becomes 1, right? So if it is 0 and this is 1, that means this is 0. Again, this 0 is inverted to 1, right? Here in this case, this is 1, 1. Again, this is converted to 1. 1 is inverted and comes to 0, right? If it is 0, then this is 1, and this becomes 1 into 1 is 1. It becomes 0 again, right? So it converted to 1 from 0. So if Q is 0, then Q complement is 1, right? So whatever is there inside memory is complemented in each and every stage, right? So as and when you pass input to the circuit, whatever is stored is complement, right? Again, if clock pulse is passed to circuit, whatever is there inside memory is inverted, right? And becomes 0. So we are at certain state that if 1, 1 is SR input, then in J and K combination will get Q complement, right? Or whatever is there inside memory is complemented, right? So we are at certain state, right? So this is called, a J and K, or use of J and K input, or use of feedback connection, right? We converted actually whatever is stored is complemented. Either if my input, or if my memory holds 0, it is inverted to 1 in one clock pulse. In another clock pulse, if it is 1, it is again inverted to 0, right? So this is how the things are going on, right? It depends on clock input. So this is how is converted from J to JK input, and this is about J and K flip flop. इथपर्यंत समजलं का J and K मध्ये काय होत आहे? ओके, हे समजलं का J आणि K मध्ये काय होतं? Okay, now this is, the condition where if 1 1 is there, in that case output is Q complement, or the complement of stored value, right, is there in J and K flip-flop. But it arises a race around condition. Race around condition is arises in this case. Now, what is race around condition is, see, race around condition is, the things are there, or as and when you pass input to circuit and you pass a clock signal, right? So clock signal is like, this is a signal you pass to this. This is positive leading edge. This is negative leading edge. What is positive leading edge is from 0 to 1 or 0 to high. And what is negative leading edge is from high to low, right? So this is basically a single clock pulse. When you pass this to a circuit, this is basically a single clock pulse. So what it should do is, when you pass this clock pulse, a signal, it should convert input to output, right? So what uh, is happening actually here is, there are certain gates available, right? So keep in mind and concentrate on my words. Those are inputs, right? Those are inputs, and this is my output. So the time taken for this conversion, right, from input to output is called propagation delay. Is called propagation delay. So conversion from input to output is propagation delay, and that propagation delay is very, very less than this clock signal, right? If you check overall those gates and time, basically this is in nanosecond, right? Basically this is in nanosecond. If you check on frequency oscillator, this is in nanosecond, uh, and clock signals are basically in milliseconds, right? So the propagation delay is less, right? That means conversion of this flip-flop will be done in this time span, right? एवढाच टाइम स्पॅन मध्ये कन्व्हर्जन होतं इनपुट टू आउटपुट. मग काय होतं बाकीच्या राहिलेल्या या सगळ्या टाइम मध्ये, तर ते काय करतं, परत त्याला काय वाटतं की परत इनपुट आले, मग परत काय करतं, त्या टायमिंग मध्ये काय करतं, इनपुटचं आउटपुट करतं, परत त्याला काय वाटतं इनपुट आलं. सो अगेन दे आर ट्राइंग टू कन्वर्ट द इनपुट टू आउटपुट. म्हणजे काय, तर झिरोचं वन करायचं, वनचं झिरो, परत झिरोचं वन, वनचं झिरो, असं कंटिन्यू करत राहतं. ही जी स्टेज आहे, दॅट स्टेज इज कॉल्ड रेसिंग. आउटपुट ऍक्च्युली रेसिंग व्हायला लागले, 0 to 1, 1 to 0, अगेन 0 to 1. हे कशामुळं, तर हा जो टाइम डिले आहे, प्रोपोगेशन डिले, म्हणजे काय, तर हे इनपुट्स आहेत, हे इनपुट्स आउटपुट व्हायला जो टाइम लागतो तो खूप कमी आहे. कशापेक्षा कमी आहे, तर हा क्लॉक सिग्नल पेक्षा. तो तो एकदा क्लॉक सिग्नल जो असतो तो पास केला तर त्या केसमध्ये ते कंटिन्यू चेंज करत राहतं, राईट. अँड दॅट इज वाय दिस आउटपुट इज रेसिंग, राईट. अँड दिस कंडिशन is basically referred as race around condition, right? This condition is basically referred as race around condition, right? या केस मध्ये तो सतत इनपुट टू आउटपुट, आउटपुट टू इनपुट असं चेंज करत राहतं, राईट. सो दिस इज वाय. आता हे कशामुळे होतं, ऑब्विसली फीडबॅक कनेक्शन दिलेत, तर त्याला प्रत्येक वेळी काय वाटतं की एकदा आउटपुट आलं की परत ते चेंज होतं, परत चेंज होऊन इनपुट होतं. सो त्या केसमध्ये क्लॉक सिग्नल त्याच वेळेस चालूच असतो. सो त्याला काय वाटतं की परत इनपुट आले, जे ते चेंज करत राहतं, आणि त्याच्यामुळे काय होतं, रेसिंग होतं आउटपुटचं, म्हणजे 0 to 1, 1 to 0, 0 to 1 असं कंटिन्यू चेंज होत होतं. अँड दॅट कंडिशन इज रेफर्ड ॲज रेस अराउंड कंडिशन. कळलं का इथंपर्यंत? कळलं का इथंपर्यंत? ओके. काही प्रॉब्लेम आहे का? कोणाला समजलेलं नाही असं आहे का? कोणाला समजलेलं नाही असं आहे का? ओके. सो याची रेमेडी बघूया का आता? रेस अराउंड कंडिशन. ओके. याची रेमेडी काय आहे? तर आता हे हे काय होतं, कंटिन्यू रेस होत राहतं 0 to 1, 1 to 0. सो त्याची रेमेडी त्यांनी आयडेंटिफाय काय केली, की मास्टर स्लेव्ह अरेंजमेंट करा. राइट? मास्टर स्लेव्ह अरेंजमेंट करा. JK फ्लिप फ्लॉपची. राइट? JK ची मास्टर स्लेव्ह अरेंजमेंट करा. म्हणजे काय? तर आता हा एक फ्लिप फ्लॉप आहे. हे सपोज SR किंवा JK काही कन्सिडर करा. नेक्स्ट याचं right. So this is how things are there. हा जो आहे हा मास्टर फ्लिप फ्लॉप हे आहे हे स्लेव्ह फ्लिप फ्लॉप. इथं काय करायला लागतं फक्त यू शुड कनेक्ट क्लॉक इनपुट इन सच अ वे दॅट हे ज्यावेळेस 1 असेल त्यावेळेस इकडं इन्व्हर्ट करायचं आहे 0. राईट? अँड अप्लाय टू धिस. राईट? म्हणजे हे ज्यावेळेस 1 असेल त्यावेळेस इथं काय होईल 0. म्हणजे ज्यावेळेस मास्टर ऍक्टिव्हेट असेल, राईट, ऍक्टिव्हेट असेल त्या केसमध्ये हे 0 आहे. म्हणजे हा डिऍक्टिव्हेट असेल. राईट? अँड पास फीडबॅक फ्रॉम स्लेव्ह टू मास्टर. राईट? पास फीडबॅक फ्रॉम slave to master. Right? In this case, हा ऍक्टिव्हेट आहे म्हणजे हे इनपुट होतील आणि या केसमध्ये हा ज्यावेळेस 0 होईल त्यावेळेस सगळे हा 0 असेल त्यावेळेस इन्व्हर्ट होऊन हा 1 होईल आणि हा 1 झाला की हा स्लेव्ह ऍक्टिव्हेट होईल आणि फीडबॅक कनेक्शन काय करायचे फ्रॉम स्लेव्ह टू मास्टरच्या इनपुटला द्यायचे. दिस इज हाऊ वी कॅन अवॉइड दी रेस अराउंड कंडिशन. अजून एक काय होतं की हा एक ऍक्च्युली वे आहे आणि हा म्हणजे काय करायचं तर हा क्लॉक सिग्नल जो दिलाय हा क्लॉक सिग्नल याच्या एवढा स्मॉल करायचा विच इज प्रॅक्टिकली नॉट पॉसिबल. राईट? हा एक वे होता की जर तुम्हाला इनपुट प्रॉपर रेसिंग होऊ द्यायचं नसेल तर त्या केसमध्ये हा जो क्लॉक सिग्नल आहे तो त्या प्रोपोगेशन डिले किंवा ते कन्व्हर्जन होतंय त्या टाइमला आणून ठेवायचा जे प्रॅक्टिकली इम्पॉसिबल आहे. म्हणून त्यांनी काय केलं की हे सोल्युशन काढलं की मास्टर स्लेव्ह अरेंजमेंट केली. मास्टर स्लेव्ह म्हणजे काय मास्टरला एक क्लॉक सिग्नल स्लेव्हला एक दुसरा क्लॉक सिग्नल इन्व्हर्टेड आणि फीडबॅक शुड बी come from slave to master, right? So this is how master slave looks like, right? And master slave is used to avoid race around condition. कळलं का अरेंजमेंट कशी आहे मास्टर स्लेव्हची? मास्टर स्लेव्हची अरेंजमेंट कळली का? ओके. याच्यात काही प्रॉब्लेम आहे का? Okay. Now next is D flip flop and T flip flop. राईट. आता डी फ्लिप फ्लॉप म्हणजे काय? डिले फ्लिप फ्लॉप किंवा डेटा फ्लिप फ्लॉप. आणि टी फ्लिप फ्लॉप म्हणजे काय? तर टॉगल फ्लिप फ्लॉप. आता एस आर चीच कंडिशन ज्या आहेत ना, एस आर मध्ये काय होतं बघा, एस आणि आर जर 0 1 असेल तर इथं झिरोच राहतं. 1 0 असेल तर इथं सॉरी, हा, हा सेट होतो. राईट. सो इथं जी कंडिशन आहे तीच आउटपुटला, इथं जी कंडिशन आहे तीच आउटपुटला येते. राईट. सो त्या केसमध्ये हे इन्व्हर्टेड आहे. सो राईट. सो दिस इज डी इनपुट अँड दिस इज युअर आउटपुट. राईट. सो फक्त डिले होतं आउटपुट. जे काही तुम्ही इनपुट द्याल ना तेच इनपुट इथं घेतो. सो दिस इज हाऊ युअर टी फ्लिप फ्लॉप लुक्स लाईक. आणि सॉरी, डी फ्लिप फ्लॉप लुक्स लाईक. आणि टॉगलला काय? टॉगल म्हणजे काय? तर दोन्हीला तुम्ही 1 1 पास करता. राईट. त्या केसमध्ये तो टॉगल होतो कंटिन्युअसली. टॉगल म्हणजे 0 to 1 1 to 0 अगेन. राईट. सो दिस इज हाऊ टी फ्लिप फ्लॉप लुक्स लाईक. राईट. टॉगल होतो म्हणजे काय, तर क्यू ची जी काही व्हॅल्यू असेल ती कंटिन्युअसली इनपुट चेंज करत राहतात. सो या केसमध्ये 1 1 ला टॉगलिंग होतं. राईट. रेसिंग जे म्हणतो तेच टॉगलिंग होतं. राईट. सो दिस इज हाऊ डी फ्लिप फ्लॉप आणि टी फ्लिप फ्लॉप लुक्स लाईक. ओके. इथंपर्यंत कळलं का? काय काय झालं आपलं? 1 bit memory cell, SR flip-flop, clocked SR flip-flop, asynchronous input like preset and clear. Then JK flip-flop arrangement is like feedback connections are there as an input. Then त्याच्यात काय होतं? रेसिंग. JK flip-flop मध्ये रेसिंग होतं किंवा रेस अराउंड कंडिशन होते. मग त्या केसमध्ये काय? मास्टर स्लेव्हची अरेंजमेंट. राईट. देन डिले फ्लिप-फ्लॉप अँड टॉगल फ्लिप-फ्लॉप. दिस इज ऑल अबाउट फ्लिप-फ्लॉप. इथपर्यंत समजलं का तुम्हाला? याच्यात काही प्रॉब्लेम आहे का?